Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to mechanics and the chapters of mechanical actions and equilibrium of a body. This exercise was the previous one in the brevet exams in 2012 first session, third exercise. The title of this exercise is Solid on an Inclined Plane. A solid S having the shape of a cube of side A is equal to 10 centimeters. Then A is equal to 10 centimeters. Knowing that centimeter is not the SI unit of length, in order to convert from centimeters to meter, we divide by 100. Then 10 divided by 100. So the side of the cube is given by 0.1 meters. Is placed on a very smooth inclined plane, negligible friction. So here, the friction between the solid S and the inclined plane is neglected because the inclined is very smooth, as shown in figure 3. And now they mention figure 3, we can use it. The density of S is given by rho is equal to 2000 kilogram per meter cube. And given that the G is equal to 10 newtons per kilogram. So notice that here they gave me the side of the cube, so we can directly determine the volume of this cube. Knowing the volume on the density, one can determine the mass. Knowing the mass and G, we can calculate the magnitude of the weight vector W, which is W. So number one, indeed they are telling me to calculate the volume V of S. So since S is classified as a regular shape, which is a cube, then the volume can be determined from the following formula, that V is equal to A to the power 3. What does A represent? A represents the side of the cube. So we use the value in the SI, which is 0.1 meters. 0.1 to the power 3. Plugging this on the calculator, it will give me 1 times 10 to the power minus 3. Since the side is in the SI, so V will be in the SI, which is meter cube. Then the volume of this cube is given by 1 times 10 to the power minus 3 meter cube. Now in number 2, they are telling me to show that the mass of S is given by M is equal to 2 kilograms. Now we know the volume and we know the density. We can determine the mass from the following formula, that the density is equal to the mass, capital M, divided by V. Now constructing the triangle of this formula, since here we have divide, so rho will be at the bottom, M at the top, and V here. So we are interested in calculating the value of M, which is given by density multiplied by the volume. Now the value of the density in the SI is given by 2000, and V is given by 1 times 10 to the power minus 3. Plugging this on the calculator, it will give me 2. Since both the density and the volume are in the SI, so the value of M will be in the SI, which is kilograms. Then M is equal to 2 kilograms. Now in number 3, they are telling me calculate the value W of W. So here W without a vector represents the magnitude of the weight vector W. And we know that the magnitude is given by M multiplied by G. The value of M that we have already calculated, which is capital M here, is given by 2. And the value of G is given by 10. This will give me 20. Since both M and G are in the SI, so the value of W will be in the SI, which is in newtons. So W is equal to 20 newtons. So what does this value represent? This value represents the fourth property of the weight vector W. Now in number 4, they are telling me to give the line of action and the direction of the weight W, knowing that the weight W always acts on any object having a mass vertically downward. Then the line of action is vertical, and the direction is downward. And now in number 5, so let me make some space here. Now in number 5, they are telling me to redraw figure 3 and represent on it W using the scale 1 centimeter corresponds to 5 newtons. and hereby represent, they mean that we need to draw the vector w. In order to draw the vector w, we need to determine the length of this vector, and this can be determined using the scale, knowing that we already calculated the magnitude of this vector. So each 1 centimeter corresponds to 5 newtons. What about the 20 newtons? Now if we crisscross, then 20 multiplied by 1 divided by 5, this will give me 4 centimeters. Here we are determining the length of the vector because we know that our rulers are graduated by centimeters and not by newtons. So let me redraw figure number 3. So this is the inclined plane. This is the solid S. And let's suppose that this point represents the center of gravity of the solid S, which is a G, because we know that the weight acts on the center of gravity vertically downward. Now, the weight vector acts at the point G vertically downward. The length of this vector is given by 4 centimeters. So this is 1, 2, 3, 4 centimeters. According to the scale, which is worth of 20 newtons, and the name of this vector is W. Now in number 6, they are telling me that S is submitted to its weight W and another force. Give the name of this force and specify for each of them whether it's a contact force or force acting from a distance. Here, because we have a plane or an inclined plane, then we know that the solid S will be subjected to the reaction at the support. So the other force is given by the reaction at the support, or the normal reaction. Let me say normal reaction. And vector. And we need to specify for both forces, for each of them. So for both forces, whether it's a contact force or force acting from a distance, we know that the weight W, this is the first force, is acting from a distance. And the other force, which is given by the normal reaction N, is a contact force, because we know that the only 3 forces that are classified as an action at a distance are given by the weight, the electric, the magnetic, and all other forces, in particular the normal reaction, is classified as a contact force. Now in number 7, they are telling me that S is not at rest, justify, and here by S is not at rest, it means that not at equilibrium. Then in order to justify that S is not at equilibrium, let's represent the other force, which is given by the contact force N, on the given diagram. So because N is a contact force, then its point of application, it will be the point of contact between the two bodies that are at interaction. So let's suppose that this is the point A. The two bodies are given by the solid S and the inclined plane. And we know that the normal reaction is perpendicular to the support like this. So this is the normal reaction N. Notice that here I have represented N without using a scale. Now in order for the solid S to be at equilibrium while subjected to 2 forces, both forces must have the same line of action, opposite direction, and same magnitude. But notice that here the line of action of the weight W is vertical, where the line of action of the normal reaction N is oblique. Then let's say since W and N don't have same line of action, then S is not at equilibrium. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.